Hi guys, today I'm going to talk about ionic compounds. So if you have a notebook, this is the time to get it out, or if you need to get some paper. Also, if you requested a paper periodic table, hopefully you've gotten it by now. You're going to want to have that out as well so you can jot some notes on it. First, I'd like to do a little review of atoms versus ions. Remember that atoms are electrically neutral. That means they have the same amount of protons or positives and the same amount of electrons or negatives. Ions are atoms, or sometimes they are a group of atoms that have a charge. This means there will be different numbers of protons and electrons. Remember that only electrons can move. The number of protons has to be constant or the element changes. Atoms or groups of atoms can either gain or lose electrons. We're going to focus on ions, and the first type of ion is called an anion. An anion is a negative ion. This means that an atom has gained electrons. On the periodic table, the nonmetals are the elements that gain electrons. These are found at the right side of the periodic table, on the right side of that staircase that is drawn. When you look at this periodic table, anything on this side is a nonmetal. Hydrogen is also sometimes classified as a nonmetal, but hydrogen is very special, so it's got a lot of very special powers. But for our purposes, think of everything to the right of that black line as a nonmetal. When atoms turn into anions, or any type of charged atom, the charge is written as a superscript on the right. If you look at this notation here, you'll see that we have F, which stands for fluorine, and it has a charge of -1. You see it's written as a superscript over here on the right. Oxygen, which is written here with the abbreviation of the letter O, has a -2 as its superscript. This means that it has gained 2 electrons. The second type of ion is called a cation. Cations are positive ions. These are formed when elements or atoms lose electrons. This means that the cation has more protons than electrons, more positives than negatives. Metals will always form cations. When we look at this periodic table here, all of the metals are found to the left of that staircase. So these are all the ones that will form positive ions or cations. We write cations the same way we write anions. We write the charge as the superscript and the element with its shorthand notation, which is just the abbreviation. So capital N, lowercase a represents sodium, and the positive is telling us that it has lost 1 electron. Magnesium, with a 2+ or a +2, either way is acceptable, has lost 2 electrons. So we write it with the abbreviation of capital M, lowercase g. Anytime there are two letters for a shorthand or an abbreviation, you always write it with a capital and then a lowercase. 2 capitals would be incorrect. To figure out the charges on ions, there's a couple of different ways to do this, but for most of them, the elements, most atoms, the type of ion they form is based on their location on the periodic table. Elements in the same group, which are the columns, have similar properties, including the charge when they are ions. We talked a little bit about why atoms are going to gain or lose electrons last week. And basically, the whole reason is they want to be stable. All elements want to be stable. And in order to be stable, they want to look like Group 18, which is the noble gases, that last column on the right on the periodic table. Okay, so now we can talk about how ionic compounds are actually formed. there is an attraction between the positive ions and the negative ions. Opposites attract. Electrons will always go from the metal to the nonmetal. So for the electron transfer, we start at the metal and the electron goes to the nonmetal, which means the metal becomes a positive ion and the nonmetal becomes a negative ion. And these are the two things that are going to attract to one another, the positive and the negative, because opposites attract. The electrons lost in the metal will always equal the electrons gained by the nonmetal. That's how the compounds are formed. I know we've talked about valence electrons before, but I just kind of want to review it very quickly. The valence electrons are the number of electrons in the outermost energy level. So remember those rings that we've been seeing a lot. The max number an element wants is 8. That's where that octet rule comes in that you guys saw last week in the gizmo. Okay. For most elements, the number of valence electrons equals the group that they're in. So for example, in group 1, they have 1 valence electron. Group 2 has 2. Okay, ignore this middle part because that's the special area. We'll talk about those. So ignore all of these right now. But then we skip and we go, this group has 3 valence electrons. Sorry, I didn't change my pen. This one has 4, 5, 6, 7, and the magic number is 8 because these guys, the noble gases, have a full outer shell of electron, the outermost layer, and they have 8. So when you look at these diagrams here, you can see that fluorine, okay, has 7 dots around it. It has 7 valence electrons. So all it needs is one tiny, tiny little electron to get 8. Well, if you look at group 1, they're trying to get rid of an electron because remember, this side, these are metals, and they want to get rid of extra electrons. Think about it. It's easier to get rid of 1 electron than to gain 7 to get to 8. Does that make sense? Okay. Same thing in group 2, this group right here. It's easier to lose these 2 electrons instead of getting 6 more. Okay. So beryllium wants to look like helium over here, right? Okay. Or it can look like, oh, I'm sorry, that was neon. Sorry, guys. It wants to look like helium behind it. So it's easier for it to lose 2 electrons and look like helium than it is to gain 6 electrons and look like neon. Let me say that again. What if we have magnesium? Magnesium has a choice. Magnesium can gain 6 electrons to look like argon, or it can lose and go backwards to neon over here and look like neon. So it's easier to lose the 2. This chart is so that you can see how ionic charges are figured out. So if you take a look, this first column are all going to have a +1 charge because they want to lose 1 electron. The second column wants to lose 2 electrons. So it has a +2 charge. We're going to skip over this middle area because these have variable charges, which means they can change, whereas these are the ones that I just showed you are fixed charges. So this column is fixed, this column is fixed, and then these are all fixed as well. When we look at this column here, which is right here, these have a +3 charge, okay? And then we've got plus or minus 4. This column's kind of unique because it could have either one, mainly because it can either add 4 electrons or it can lose 4 electrons to look like a noble gas. It's right in the center if you think about it, of 8. Okay, now on this side we're in the nonmetals, so this is going to be a -3 charge column, a -2 charge column, a -1 charge column, and then this noble gases don't have any charge at all. So this is just kind of an example. This is something you might want to jot down on your periodic table if you have one. Just at the top of each column, put the charge so you know, and that way you'll have it as a reference. Okay, so here's a periodic table, and I'm going to pose a few questions for you to try to answer, so you can use the periodic table in order to do that. If you have any questions, be sure to ask, send me a message, or come to office hours. Have a great day.